Hello everyone, this is Kripaki from Sri Venkateshwara College of Engineering, studying Computer Science and Engineering, currently in 6th semester. In this video, I'm going to be talking about a topic from the subject Data Mining and Data Warehousing, subject code 18CS641. I'm going to be talking about what is multi-tier architecture of data warehousing. The contents being covered in this video are what is data warehouse, multi-tier architecture of data warehouse, bottom tier, middle tier, top tier, and advantages of multi-tier architecture. Moving to the topic, what is data warehouse? A data warehouse is a repository of information collected from multiple sources stored under a unified schema and which usually resides at a single site. Data warehouses are constructed via a process of data cleansing, data transformation, data integration, data loading, and periodic data refreshing. Data warehousing provides architectures and tools for business executives to systematically organize, understand, and use their data to make strategic decisions. So this is all about data warehouse. Moving to multi-tier architecture of data warehouse. Data warehouses often adopts a three-tier architecture such as bottom tier, multi-tier, and top tier. So let us see what's there in bottom tier, multi-tier, and top tier. So this is the pictorial representation of a three-tier architecture. As you can see, it consists of the top tier, multi-tier, and bottom tier. What is bottom tier? The bottom tier is a warehouse database server that is almost always a relational database system. Backend tools and utilities are used to feed data into the bottom tier from operational databases or other external sources. These tools and utilities perform data extraction, cleaning, and transformation, as well as load and refresh functions to update the data warehouse. The data are extracted using application program interface known as gateways. A gateway is supported by the underlying DBMS and allows client programmers to generate SQL code to be executed at a servers. Examples of gateways includes ODBC by Microsoft and JDBC. This tier also contains a metadata repository which stores information about data warehouse and its contents. A bottom tier that consists of the data warehouse server, which is almost always an RDBMS. It may include several specialized data marts and metadata repository. Data from operational databases and external sources are extracted using application programs interface called a gateway. A gateway is provided by the underlying DBMS and allows customer programs to generate SQL code to be executed at a server. Examples of gateways are ODBC, Open Database Connection, and OLEDB, Open Linking and Embedding for Databases by Microsoft, and JDBC, Java Database Connection. Moving to middle tier. The middle tier is an OLAP server that is typically implemented using either a relational OLAP model, that is an extended relational DBMS that maps operations on multidimensional data to standard relational operations, or a multidimensional OLAP model that is a special purpose server that directly implements multidimensional data and operations. What is ROLAP? These are intermediate servers which stand in between a relational backend server and user for front-end tools. They use a relational or extended relational DBMS to save and handle warehouse data and OLAP middleware to provide missing pieces. ROLAP servers contain optimization for each DBMS backend, implementation of aggregation, navigation, logic, and additional tools and services. ROLAP technology tends to have higher scalability than MOLAP technology. ROLAP systems work primarily from the data that resides in a relational database where the base data and dimension tables are stored as relational tables. This mode permits the multidimensional analysis of data. This technique relies on manipulating the data stored in the relational database to give the presence of traditional OLAPs, slicing and dicing functionality. In essence, each method of slicing and dicing is equivalent to adding a where clause in the SQL statements. Talking about multidimensional OLAP server. A multidimensional OLAP server system is based on a navigate logical model that directly supports multidimensional data and operations. Data are stored physically into multidimensional arrays and positional techniques are used to access them. One of the significant directions of multidimensional against a relational OLAP server is that data are summarized and are stored in optimized format in a multidimensional queue instead of a relational database in multidimensional model. Data are structured into proprietary formats by clients reporting requirements with the calculations pre-generated on the cubes. So this was all about relational OLAP servers and multidimensional OLAP servers. Moving to top tier, a top tier that contains front-end tools for displaying results provided by OLAP as well as additional tools for data mining of the OLAP generated data. The metadata repository stores information that defines DW objects. It includes the following parameters and information for the middle and the top tier applications. A description of a DW structure including the warehouse schema, dimension, hierarchies, data mart locations, and contents, etc. Operational metadata, which usually describes the currency level of the stored data that is active, achieved, or plugged, and warehouse monitoring information, that is usage statistics, error reports, audit, etc. System performance data, which includes indices used to improve data access and retrieval performance. Information about the mapping from operational databases, which provides source, RDBMS, and their contents, cleaning and transformation rules, etc. Summarization algorithms, predefined queries and reports, business data, which include business terms and definitions, ownership information, etc. Moving to the advantages of multi-tier architecture. There are 7 advantages of multi-tier architecture. Scalability, better performance, modularity, security, improved resource management, easier maintenance, improved reliability. Scalability, various components can be added, deleted, or updated in accordance with the data warehouse, shifting needs and specifications. Better performance, the several layers enable parallel and efficient processing, which enhances performance and reaction times. Modularity, the architecture supports modular design, which facilitates the creation, testing, and deployment of separate components. Security. The data warehouse overall security can be improved by applying various security measures to various layers. Improved resource management. Different tiers can be turned to use the proper hardware resources, cutting expenses overall and increasing effectiveness. Easier maintenance. Maintenance is simpler because individual components can be updated or maintained without affecting the data warehouse as a whole. Improved reliability. Using many tiers can offer redundancy and failover capabilities, enhancing the data warehouse's overall reliability. So this is all about the advantages of multi-tier architecture. I hope this video could be of great use for learning about multi-tier architecture of data warehouse. Have a nice day. Thank you.